This video is on the most important topics of electricity. Electricity is one of the biggest topic of paper 1, and the topics which I'm covering in this video are the one which are most asked in all of the previous year's exam questions. And let's just get started. So now these are the most common electricity equations. You don't have to learn them because they will be there in your equation sheet, but you need to understand and you should know how to rearrange the equations. So I'm just going to work with one or two. So I'm just going to start with the first one here. So the Q is a symbol for charge. You need to know the units. You're writing the physics paper, so it's triple. And you also need to know that the conversions, sometimes you will have the conversions of millicoulombs or milliamps. So whenever you have this word milli, you always need to convert it into amperes or coulombs by dividing by 1000. Okay, so this is a 1/1000 amperes. So divided by 1000. Energy, you'll know it is measured in joules. And Q is again charge, V is potential difference measured in volts, P is power, which is measured in watts, V is again potential difference, I here is current, is measured in amps, but most of the times the question would have the data in milliamps, so do not forget to convert this into amps. Now the power is again in watts. Now the rearrangement part is, I'm pretty sure because you're writing the physics paper, that is not much of a trouble. So I'm just going to write it here. Okay, and just rearranging, if they ask you for current, this would be charge divided by time. So you will have these equations in the equation sheet. Energy is charge times potential difference. You'll have these equations in the equation sheet, but you need to be able to rearrange them. Also, the electricity questions are mostly related to energy equations. These are the equations which are mostly found in the electricity questions. So now this one is whenever there is a temperature change involved. So let's say a question would be, a motor is used to lift up some amount of water, and which in process raises the temperature of the water. So whenever there is a temperature change, remember to use the equation that has the word C, which is specific heat capacity. So wherever you have the equation sheet with you, then you can just see that equation which has the specific heat capacity in it. The energy equals to mass times specific heat capacity times temperature change would be used whenever there is temperature change involved and energy transfer involved. This equation whenever there is a state change involved. So for example, a heater is used to melt ice. So you're melting ice, energy is coming from the heater and it is melting ice, so you need to use this equation. So L here is latent heat. So I'm just writing here. So L here is latent heat. So when is latent heat used? Whenever there is a state change. You only need to know this very superficial. There's no in-depth questions asked. So whenever you see energy transfer or heating happening and there's a state change happening, just link it with this equation in your equation sheet. Now obviously now this one is the potential energy equation, the gravitational potential energy, where M is the mass, G is gravitational field strength. Okay, the value of this would be given in your question. So whenever there is a change of height involved, you will have to use gravitational potential energy. So let's say a motor is lifting, again I'm just talking about lifting some object to some height. So if this is lifted up, so the energy that is imparted to this by an electrical motor is converting into its potential energy. And where is the motor getting its energy from? It is getting its electrical energy transferred through whatever the power station is, let's say using some nuclear fuel. So the nuclear energy store of the power station stores changes to the thermal or the gravitational potential energy stores of this ball electrically or mechanically. So, and also the fourth one is efficiency, useful output power divided by total input power, or useful output energy divided by total input energy. Okay, now this is one of the exam questions. I will show you the solution in a minute, but what I just want you to remind you is, see this gram here. Remember, mass is the standard unit of mass is kilograms. So whenever you see grams, you need to convert it, dividing by 1000. Okay, so this is 0.15 kg. Now this is in standard units. Now this is again not a standard unit because kilojoules is not a standard unit. You need to times it by 1000 to get the required energy unit, that is joules. Now calculate the temperature increase. Now, so obviously now you have the energy equation as mass times specific heat capacity times temperature change. So this requires rearrangement. Always show your working, because sometimes you can make mistakes in some conversions. You can make mistake, see how I'm making mistake here. You can make mistake in your calculator can make mistake in writing the units or in numbers. So what you need, if you show the calculations, if you show the steps, so now this rearrangement step itself gives you the 1 mark before even I plug in any values. So always show the working out. Okay, so I'm just going to do this one quickly. So this one is 5400, and then you divide it by 0.15. Specific heat capacity is 900, and that gives you temperature change. Okay, I'll show you the answers. The answers are, okay, in a minute I'll just show you the answers. So this one now is just asking you temperature change. Now let's see what's the other question asking you. Now this one is asking you, so your battery has a potential difference of 6 volts. Now again, see the energy is given it again kilojoules. You need to convert energy always into joules. Charge flow, say using energy equals charge times potential difference. Just plugging in the values divided by potential difference, 6 volts is going to give me the charge. Okay, so which is I think 12,000 coulombs. Do not forget to write the units. The warmer has 2 identical heating elements connected in parallel. So something has 2 heating elements. I'm going to just draw. Heating element is nothing but a resistor. So let's say this is a switch, and then another heating element in parallel, and you connect the warmer to your supply. Okay, so I have this foot warmer, so it is connected to the electricity supply of my home, and not only my home, your home, every other home in UK gets this 230 volts. So when the second heating element is switched on, so if this is switched on and I switch this one on too, so what then happens? Now what this is interested in knowing is whether you can understand that in parallel the total resistance always decreases. Now once the total resistance decreases, what would happen to the current that comes from the supply? The total current is going to increase because supply potential difference is same. So the total current increases, hence the power output from my foot warmer is going to increase because power output is what? Is potential difference times current. The potential difference is same, 230 volts, but the current has increased because you have switched on this parallel circuit. The parallel circuit means the resistance decreases and the current increases. Power output increases then. Okay, so you can pause the video and check the answers. Now this one, I'm just going to quickly go through the units. So centimeters always convert into meters divided by 100. Grams always into kg divided by 1000. Milli, so this small is again milli. Everywhere you have a milli, always convert it into the original units of milliwatts, converts to watts. Again, a milli here. Minutes should always be in seconds times by 60. Okay, now, so this is your answer. Pause and check your answers, but first do the question yourself. Again, then pause and check your answers. Now, the circuit behavior. Now, this is one of the most favorite topics of the examiners. They would test one of these things. So we've already seen a little bit of parallel circuit. So again, I'm just going to see here. So if I have a series circuit, what would happen in a series circuit? Understand that in a series circuit, the potential difference divides always. So if this is, let's say, a 6-volt battery, this would give 3 volts to this one if they both are identical. The current, whatever current comes out from the battery, let's say this is 2 amp currents, the same 2 amp will go into both of the resistors, if it's a resistor or a filament bulb or whatever. So the current in the series is same. More resistors in the circuit means the total resistance would be higher. So resistance increases. So when you add 2 or more resistances in series, the total resistance always increases. Current remains same. Every element would have same current. For example, if you have the Christmas light, which were used in old times, so every single bulb of the Christmas light would carry the same current because they are all in series. What that means is, if someday one of the bulb fuses, then none of the bulbs would work because it's series. One bulb goes off. So I'm going to make it here. So the one bulb goes off. So let's say this bulb breaks. So the current will stop flowing because this is an incomplete circuit. If it is a parallel circuit, in a parallel circuit, current divides. Okay, so let's say this one is one lamp here and another lamp here. Please remember that you need to draw it neatly like this one, not like this one. So in a parallel circuit, so the current would then divide. Let's say if I have 10 amp current here coming from a 6-volt battery, so then what would happen is 5 amp goes in this bulb and 5 amp goes in this bulb if they're identical bulbs. And the potential difference, this one also gets 6 volts and this one also gets 6 volts. And total resistance is always decreased. And this is how, so we have circuits in our home. Every single thing in our home is in parallel circuit. So what happens is, if one bulb fuses, let's say if this one fuses, this one will still carry the current. Right, so that's why every single thing in our home is in parallel circuit. Let's say for one day your electric kettle stops working, that doesn't mean that everything else, your TV stops working, your lights stops working. Everything will keep on working because everything in our home is in a parallel circuit. Okay, now role of switches. Why do we have switches? Switches is for disconnecting the circuit. is for stopping the flow of current. So when you have more branches added, it's because in parallel, the total resistance always decreases. The more number of branches you have, less is the total resistance, and hence higher is the current. So that's what, so when you switch on more and more appliances in your home, how come nothing get affected? Because everything you switch on, the circuit resistance, the total resistance of your house decreases, and it draws in more current from the supply. Remember, supply voltage remains same. It is the current that changes. Now, output power, how output power will change? So let's say in this case, say, let's just go here. So how the output power would change if I have a single bulb switched on. Okay, this is just the question that we did previously. So if I have a single bulb switch on into the circuit, or if I have two more bulbs switch on, go ahead, pause the video and try to answer it yourself. I'm going to answer anyways. Say if I have three bulbs, so then what would happen? So supply is, let's say I have a battery which gives 10 volts. This is a DC supply. So if I switch this one on, whatever the current comes in, the minute you switch this on, that current would increase. So the current is increased, but the potential difference is still the same. So power would increase, because power is voltage times current. I is for current. You switch on another one, total resistance is further decreased, I increases, and power increases. Okay. Short circuits. Now, what is the meaning of a short circuit? A short circuit means that the current would have a very less resistance path. So the word short circuit, I'm going to just go here, I'm going to write here. So short circuit means almost zero resistance path. So if it's a zero resistance path, the current would be very high. So very high current. So that's the meaning of short circuit. And short circuits are, that's why, very dangerous, because the currents are very high. Okay, now also you need to know the graphs and different components. Filament lamp. So let's just go here. Let's start with the filament lamp. Just going to write. So lamp, the graph is, because the shape of the graph is not straight line. Why does this happen? Is because as the lamp gets hot, the resistance increases. If the question asks you to explain why the resistance increases, you just explain because the metal atom in which the current is flowing starts vibrating more vibrations, more collisions between the electrons that are flowing. Say, let's say this is the wire, and every wire would have some atom. Everything is made up of atoms, right? In this this wire, now you have the electron which is trying to flow, and if they start vibrating, if these atoms start vibrating, the electron which is trying to flow will end up colliding more. It collides more, it loses energy, flows less current, high resistance. Okay, so more vibrations, more collisions, these would be the words which you would be using, and hence resistance increases. And that's why, because resistance is not constant, the graph is not a straight line. If you then have, of course it's a filament lamp, if you then have, let's say, a diode, so what would be then the diode? The diode is the one that allows current only in one direction, when your potential difference becomes negative, so the potential difference becomes negative, the current becomes zero. See, on the right hand side there is no current, but in the lamp there is a current on the right hand side. Even when the voltage is negative, current is still there. So diode allows current only in one direction. That's why its symbol also have an arrow in its symbol. Current only in one direction. The third one is a resistor. So a resistor would be the one for which the graph is a straight line. So this is I and this is V. Now what is happening here is we're assuming that the total resistance is constant. There's no change in the resistance, unlike the lamp whose resistance is changing when it is hot, unlike the diode whose resistance is changing with the applied potential difference. Very high resistance when the voltage is negative. As you can see, current is zero here. That means the resistance is very high. Next one is a thermistor. Thermistor, now this graph is between resistance and temperature. Higher temperature, lower resistance. So as you can see, when the temperature is low, resistance is very high. As temperature increases, resistance decreases. That's your thermistor. And similarly, you need to know for a light dependent resistor, as the light intensity increases, the resistance decreases. They are both similar graph, similar shaped graph. One increases, temperature increases, resistance decreases, light intensity increases, resistance decreases. So light dependent resistor. So these are the components whose graphs you need to know. Symbol for diffuse, I'm pretty sure you all know that, but this is one of the common things which examiners love asking. So this is the fuse. What's the role of the fuse? It disconnects the circuit when the current is high, so that your electrical device or the circuit is not damaged. LED is a light emitting diode. So diode is an arrow, one direction, and then it emits light. So see how the arrow is outwards, it's emitting light. Thermistor is a temperature dependent resistor. Okay, so it's a temperature dependent resistor. Now, question again, before you attempt the question, pause the video and try to do it yourself. I'm just going to tell you, convert milliamps to amps, convert minutes to seconds, and then check your answer. Now, to start, if you are watching a video and you're not doing triple, then this is the topic you don't need to know. The static electricity, just go forward the video and go ahead. Static electricity, you don't need to know. Now, if you're doing triple, these are the topics which generally come from this, repeated in the exam questions. Electron transfer. So whenever you rub a body A with body B, let's say you're walking on carpet, your shoes are rubbing on the carpet, your feet is rubbing on the carpet, your body gets static electricity, is because electrons, they transfer from one object to another object. That's static electricity. The charge transfers from one body to another. So whoever is losing the charge becomes positive and the other one becomes negative. And this attraction, this flow of charge, because of the buildup of charge, results into the spark that you see if you've walked on the carpet and then you go and touch the door handle, you see a slight spark. That spark is because of the static charge built up in you. And there would be attraction if it is opposite charge, repulsion if it is similar charge. One common example is the hair standing up. So the let's say I'm just trying to draw a diagram here. So a person, okay, his head hairs are standing up is because of the buildup of static charges, and because if the charges build up, and obviously the charge buildup will be same on all the strands of hair, and would they what would end up, they would end up repelling each other because it's the same charge. Okay, you don't need to know what kind of charge is this. You need to know if the charge is same on each strand of hair, they will end up repelling each other, and because of this repulsion they stand up. Explained use of spark already. Electric field. Okay, so whenever there is a charge, the region around the charge, so this plus here is a positive charge, so the region around the charge where another charge can experience a force. Okay, so it's just like magnetic field. So if there is a small magnet, if you keep another magnet very far away from this magnet which you have, the magnet will not feel attraction. It will feel attraction only when you bring both the magnets together. So region around the charge where other charge experiences force. Okay, so that's your electric field. That's the diagram. And then in static context, you should know electric field. They'll be giving you in the question, giving you charge or potential difference, and you have to find one of them. Again, the question, pause, try to do it yourself, and before attempting again, see, I'm again and again telling you, please convert. I've seen so many students losing marks because of this. We don't want to be one of them. Check your answers when you've done. And then the last one is national grid and mains electricity. Okay, it is so many times every teacher tells you 230 volts, 50 hertz. Do not forget it. We do not want to miss these 2 marks if it comes in your exam. Earth wire is earth in color, green in color. Neutral is blue. Blue is a very neutral color. Live is a brown wire. Live wire means the wire that carries current. It is the one which is connected to your supply. Okay. You have a fuse always attached to the live wire, because if the live wire touches the, let's say, the outer part of the plug or outer part of your oven or anything, it would become dangerous. The body of your oven, you don't want the body of the oven to carry current. You don't want the person who's cooking to be electrocuted. That's why the fuse wire in there is then attached to the live wire. Step up transformer is the one that increases potential difference. Step up. Why does it increase potential difference? Because it wants to decrease the current. Why does it want to decrease the current? To decrease heat losses in long distance transmission. Say we don't have any power station near our houses. Power stations are far away. So from the power station to our houses, there's a long distance. In that long distance, if there's a large current, there would be large amount of heat losses. So what they do is, near the power station, so I'm just going to make it here. So power stations create electricity, produce electricity, and then they send their electricity to step up transformer. So what it does is, it increases the potential difference and decreases the current, and then it gets transmitted to our area, let's say the area where I stay, and then in my area or your area would have a step down transformer. So what does step down transformer does? Now this one is produced at 230 volts. Step up transformer increases the voltage up to 66,000 volts. You don't need to know that, just telling you to understand the context. So step down transformer again steps it down to 230 volts. Now why? So this one, okay, just step down transformer decreases potential difference. Why does it decreases potential difference? So to make it safe for home and appliances. That's the reason why we have transformers. Once step up to decrease the losses, step down to make it safe for the home and the appliances. You cannot have an appliance running at 66,000 volts. That would be terrible. Okay, a town receives, okay, sorry, I just saw this word only. So M here is a million, so you need to get rid of that million by 10 to the power 6. Okay, go ahead, pause and try to do it yourself and then mark. Okay, so that's it. That's your electricity. I've quickly whizzed past a lot of things, so please pause, revise, and make sure you are very good at this very important and very big topic of paper 1. So well done. Till next time, take care.